Alrighty. This is going on where it says date. We'll just put going on page 71. You can put your name on it if you want to. All right, so we are going to talk about average value of a continuous function. Average value, not the value, and it has to be a continuous function. When you're talking about statistics type stuff and you're talking about mean, median, and mode, which one means average? Is it mean, median, or mode? Mean. That's why we have here the mean value theorem, which we have talked about before, but we talked about MBT, remember IVT and MBT, but it was more in a theory type of situation. Here we actually have a theorem for the integrals where it gives us a little equation, and we will come back and talk about that here in just a minute. Okay, actually we're going to come up with it. So geometric interpretation of the mean value theorem. So anytime it talks about the geometric interpretation, we're talking about the graphical, the visual part of it, not the equations and stuff. So it has all this wordy stuff, and we're looking for what we consider like the perfect rectangle. And a perfect rectangle would be a rectangle whose area is exactly equal to the area of the region under the graph. Okay, so if we have this, so if I'm going to say this is F, and it looks something like this, okay? And I want the area from A to B, okay? So when I do that, this is the area under the curve, right? Looking for that, which geometrically, we don't really know how to find that, right? If I do the same type of graph, let me see if I can kind of make it look sort of the same. That's my goal, but you know. And then what I can find the value of is a rectangle like this, right? That's how I know how to find it, right? So f of c is the height of the perfect rectangle, all right? So this is the perfect rectangle that I'd be able to find. B minus A is the base, right? This distance here would be B minus A. That's how we find it. It's just the change in X. You agree with all that? So that means if I was going to find the area of this rectangle here, this would be my height, which is f of c times B minus A. Okay? That's where that comes from here. So what we have then is the integral from A to B of f of x dx is equal to this right here. And our perfect rectangle would mean, remember, is the rectangle whose area is exactly equal, which that's not exactly equal, but we could find it somewhere, right? We could find whatever the height is to actually make us a rectangle. When we want to figure out what f of c is, which would be our average value, to get that perfect height, then we can just divide both sides by b over a, and that's what this looks like right here. Okay, that's where that little equation comes from. I'm going to show you some other things about where it comes from. And the wording in these questions is important. Am I looking for a value or an average value or an average rate of change, or what is it that I'm looking for here? Okay, so the value f of c, so it is an average value, it's not a rate. F of c is called the average value for the function f, and this is what the little function looks like. You can put AVE, I usually use AVG, kind of really means the same thing either way. But let's look at this alternative proof. It's another way to kind of look at it, which I think this part right here makes a little bit more sense. If I have this integral right here, that I'm going to integrate from A to B, f prime of x dx. If I have f prime of c, just f prime of c, what does that represent? Anybody? Yes. Yeah, we get a little distracted there. Okay, f prime of c, what does that represent? If I take f prime represents the derivative, right? The derivative at a specific x value gives me what type of information? Or what does the derivative give me in general? The slope, right? It gives me the rate of change. So if I take the derivative and I find it at a point, it gives me what kind of rate of change? The instantaneous. Very good. So this gives me so I'm going to say this is the slope at a point, or at C, okay? And that is the instantaneous, I don't know. It's because I changed what I was going to write and I wasn't thinking. Instantaneous, I don't know how to spell this, but that looks good. Rate of change. It's okay. You don't get taken points off for spelling. It's important that you know that it is the instantaneous. It's at that one specific point. It is not an average rate of change. Okay. Now again, we're talking about average value, not the same thing as average rate of change, not the same thing as instantaneous rate of change. Okay, so then it asks you, what is the expression for average rate of change? So we're asking for right now, average rate of change. If we're talking about this here, we're talking about f, that would give us f of b minus f of a over b minus a. Okay, so think about that. This gives me the instantaneous rate of change. If for some reason I can't find the derivative, I can estimate it with the average rate of change, right? Or maybe I want the average rate of change by actually using the values from the function itself, not from the derivative. Okay, you see how those two things give you similar types of answers, but a little bit different, right? So now it tells us to rewrite this without the integral. So let's remember the fundamental theorem of calculus. Okay, so before we rewrite that, our fundamental theorem of calculus would be the integral from a to b of f prime of x dx equals, anybody tell me what it equals? It equals just plain old f of b minus f of a. Okay, does that look familiar? Right? That's what the fundamental theorem of calculus says. So what we're going to do to rewrite it without the integral, instead of this part right here, which is this, we're going to replace it with this. So when we do that, we get 1 over b minus a, and then we're going to multiply that by f of b minus f of a. And, oh yeah, I would, thank you. I was thinking about rewriting it as a fraction, but yes, absolutely. And then what do you observe, except the fact that I left off on parentheses? What does this look the same as? This is what? This is the average rate of change. Average rate of change. That's how all of that is. If I rewrote it with that as a numerator, that is the average rate of change, right? Okay, so that's how all that relates together. Basically, when we want an average value, when you see that, and the units will help you understand all this stuff as we go through too. The first couple of examples don't have any units on it, but then I'm going to show you how units will help you remember what to do in the end, okay, if you get all kind of lost in that stuff. All right, let's flip this over. So it says to find the average value on the interval from -2 to 5 of this function below. So this is the graph of f. So the average value, right, means I'm going to integrate, okay, so I'm going to integrate this, my f average, AVG or AVE is what that said, but I think that's kind of weird. I'm going to leave a little space here, okay, just a little bit of a space, and I'm going to integrate from -2 to 5, because that's what it gave me here, -2 to 5 of f of x dx. Now, if I do this is accumulation, right? It is the amount of change over that entire interval. That's not what I want. I want the average value. So once I integrate, I have to basically divide or multiply by 1 minus the change in this, which would have been the b minus a, or the 5 minus a -2. right here. Okay. Everybody okay with that? Alrighty. So then let's clean this up a little bit, or actually let's go find some areas. Can I split this into two triangles? Do I have to? No, I don't. This whole distance right here is how much? 3. And this whole distance is 3. Okay, totally doesn't really look to scale, right? But whatever. So when I do that, I should have not written that 3 in there. But 3 times 3 over 2 makes this area what? 9/2. Okay. Then this is how much of a circle? Half. What is my radius? 2. My radius is 2. So the area of the circle is, so it's 4 pi. So it's 4 pi. But this right here would just be how much? This would be 2 pi. Okay. And we've integrated visually like that before, right? And so then I'm just going to put all that together and say that that's going to equal 1 over what? What is this? 5 minus a negative 2, 7. Okay. Times, then this integral is just my areas added together, right? 9/2 plus 2 pi. Do I have to do anything else? No, I do not. And since I don't have to, I'm not going to, right? So I don't make up any math. I'm done. So we already know how to integrate. We're just taking that and finding the average value there. Okay? We okay with that? What questions you got? Okay. Let's look at this one. We are going to find the average value of f on this given interval. So again, since it says average value, right? Average value tells me that I'm going to have to do the 1 over thing. So my average value is equal to 1 over what? 2. Good. 2 minus a negative 1, because that's my b minus a, times the integral from negative 1 to 2 of 1 plus x squared dx. Okay. Everybody good with that at this point? Okay, so now I need to actually integrate my fraction out in front. What does that become? 1/3, right? And then since I have 2 terms in there, I'm just going to open my parentheses. And remember this, because this is one of the things that y'all get stuck on sometimes with these integrals, is that no matter what's going on, I have 2 terms. And no matter what's going on in the 2 terms, I'm going to treat them completely separate. I could rewrite it as 2 integrals. I don't have to rewrite it as 2 integrals. But in your brain, you at least need to keep them separate and not try and do something altogether, because that's where sometimes we're getting stuck. Okay, so if I integrate 1, what do I get? X, okay? And then plus, this would give me x cubed over what? 3, okay? And then I'm not going to put a plus c because I'm evaluating it, right? Otherwise, I can't forget my plus c. I'm going to evaluate this from negative 1 to 2. Okay? Everybody with me so far? So then when we evaluate it, we're going to start by, I'm just going to put that 1/3 there. I'm going to substitute in the negative 1. So I get negative 1 plus negative 1 cubed over 3. And then what do I do? Is that all? Am I done? Oh, did I do that right? What did I do wrong? I did it wrong. What did I do wrong? I know y'all love when I mess up. But tell me where I messed up. Is negative 1 supposed to go first? You're supposed to do the top minus the bottom, right? Caught myself. I know. It'd be better if you had a better teacher. But you got to be able to find your own mistakes sometimes too, right? The good news is I didn't completely do it wrong. All right. So what actually goes here? 2 and 2. Then what do I do after I fix my mistake? Do I add or subtract? Subtract. I subtract. I'm going to rewrite my 1/3. This is where my -1 plus -1 cubed over 3 goes. Now, do I have to do anything else at this point? I don't. So this is a safe stop. Okay? So this is a safe stop. You'll see in just a second, we are actually going to have to do more. But for this particular question, I'm done. Okay? So I'm done there. Then this part is not on the AP test, but we're just going to stretch our brains a little bit. It says, how would you find the times? And this really means the x value, the x's. This is not written well. The x's, c on the interval. So same interval. How would I find the times or when or where? How would I find where, given it being c, on this interval that f of x equals the average? So if I want to find when those two equal, I need to take the average that I found and set it equal to f of x, which is right here. So let's say this happens on the AP test where I got to a safe stop, boom. And then I move on and I realize, oh, I do actually need the value so that I can figure this out. And actually this just says how. But either way, I would then continue here and fix all this right here and not up here. Does that make sense? Because then you can get this credit for this. But if I mess up on the arithmetic here and I do it in this spot, then I'm going to lose that point. If I do it here, then, I'm less likely to lose that point. You might lose another one, but still, it's kind of half dozen to one, but either way. So let's start cleaning this up. This is going to give me 1/3 times, okay, so this is, what's 2 cubed? 8. So 8/3 plus 2. Here, let's just do 8/3. Oh, let me do 2 first, sorry. I'll just write that down first. 2 plus 8/3 minus 1/3 times -1 plus, what's the numerator? What's -1 cubed? -1. -1 over 3. Okay. Then let's combine these. 8/3 plus 2. Does that become 10/3? No, it does not. What does it become? 14/3. So I have 1/3 times 14/3 minus 1/3 times, what's -1 plus -1/3? If I combine these, I get -4/3, right? If I'm going to multiply by -4/3, I can go ahead and make that positive and make that 4/3 right there. Okay? We all good so far? Why am I not coming up with the right answer here? When I multiply straight across, I get, oh, it is right. I'm sorry. My brain was messed up again. When I get this is going to give me 14, what? 9ths? Okay, thank you. 14 9ths plus what? 4 9ths? That's going to give me 18 9ths, which is what? 2. That was a lot of work to simplify that, right? Is safe stop better? For sure. We haven't even answered this question yet, and I sort of ran out of room for that. I've got to take this 2, So it says, when is f of x equal to the average? F of x is 1 plus x squared. Set that equal to the average, which what we got was actually 2. Then I can subtract 1 from both sides, and I get x squared equals 1. So what does x equal? Don't make me scream. Plus or minus 1. Okay. Whew. That one was a little exhausting, right? But what was exhausting? It was the freaking arithmetic. That's why safe stops are really, really nice, right? Because nobody's really, and this is not on the AP test. We just thought it'd be fun to throw it in there. Wasn't that fun? It's also a good reminder to do the safe stops, right? Okay. So the table below gives the values for a continuous function. That's important. Use left Riemann sum with 3 subintervals and values from the table to estimate the average value of this. Okay? So we're using Riemann sums and we're finding the average value. So the average of anything, you add them all up and divide by something, right? That's why we're having to divide by or put 1 over something out in front when we do this. So let's do our Riemann sum. We got 3 subintervals. From here to here, that's 4. From here to here, that's 3. From here to here, that's 5. If they are left Riemann sums, we start the height. Does it come from the left or the right? It's a left Riemann sum. It comes from the left, right? So that means for 4, and I would mark those out so I don't accidentally use them. 4, I'm using 23 because it's on the left. For 3, I'm using 29. For 5, I'm using 36. Like, go ahead and connect them because Riemann sums are fairly simple, but they're also easy to mess up, right? So what we are trying to do here, here's what we want. We want the average value, okay? And so that's going to be equal to 1 over b minus a, and we're going from 5 to 17, so this is 17 minus 5 times the integral from 5 to 17 of f of x dx. Okay, everybody okay with that? All right, so then here, I'm going to, what's 17 minus 5? 1 over 12, okay, times, and then here's where my Riemann sums come in. My first one is going to be 4 times 23. Then I'm going to get 3 times 29. Then I'm going to get 5 times 36. And I don't have any units, and I don't have to do anything else, so I'm not going to. Okay? Now, I want you to look at something here. Up here, this said, find the average value. Okay, and that's what we're telling us, and we can find it exactly. This is an equal sign. Down here, we are estimating, so this needs to be squigglies. I was hoping somebody would stop me, but y'all didn't, so go in there and fix your squigglies. Okay? Because since it is an estimate, it is about this. Now, I'm estimating it's about this, but then this is an equal sign because this actually does equal this. You with me on that? Because that's what we're going with on there. Okay? How are we doing? We good? All right. Was that the end of the piece of paper you had? Okay. One more for you. This one, we're going to look at the units here and how you can figure out that you actually need a value. You know, if you get confused about, am I looking for a rate? What am I looking for? Your units can help you figure things out. Are you mad at them or something? You mad at them or something? Okay. So this is an actual FRQ, by the way. So we have the temperature of the water in a tub at time t is modeled by a strictly increasing twice differential function W, where W of t is measured in degree Fahrenheit. Okay, and it says that right there. T is measured in minutes. Values of W of t at selected times for the first 20 minutes are given in the table above. All right, so we're going to use the data in the table to estimate the average rate of change of W of t on that interval. Show the computations that lead to your answer. Use the correct unit. Interpret the meaning of your answer in the context of the problem. Okay, so I'm looking for the average rate of change. Am I going to put 1 over 20 minus 0 out in front? If I want the average rate of change, what do the units look like? If this is minutes in degrees Fahrenheit, the rate of change or the slope units would be what? Degrees Fahrenheit per minute, right? And so when I take this, that means if I'm looking for the average rate of change, how do you find the average rate of change? Do you know how to find the average rate of change? Is that what we've been doing here so far today? What have we been finding today? Average what? No. What's it called? Average value. We've been looking for average value. Average rate of change just means slope, right? An average rate of change means that you are finding the derivative, basically, right? I want the derivative, or I'm just finding plain old slope, okay? So this is W prime of t is about, because I am approximating it, right, at, well, let's see. Oh, wait, this is a different question than this. Oh, so the average rate of change, yeah. So W of t is about, I want W of what? I'm going from 0 to 20. W of what here? If I want the average rate of change on this interval, those are my numbers. Which one comes first? 20. W of 20 minus W of 0 over what? 20 minus 0. Okay, so W of 20 is 71.0 minus 55.0 over, bless you, over 20. All right, do I have to go any farther than this? No. You do need to know if you are, if it's positive or negative so that we can know if it's increasing or decreasing. But without finishing that, can you tell if it's positive or negative? So then you can leave it there and you don't even have to subtract, right? We can do this right here. Okay, so then we can say this is, or not this, well, yeah, this value represents the average increasing rate of change, or no, hang on a second, wording. This value represents mine's always extra wordy. I was trying to simplify my words and it's not working. This value, I was trying not to rewrite that and then I'm making it harder. This value represents the temperature increasing at an average rate on 0 to 20 minutes. And since we didn't write all that, this is degrees Fahrenheit per minute. We want that on there. Okay? And since it's positive, it's increasing. If it was negative, it would be decreasing at that. It would probably sound better if we actually put the number in it, but I got lazy. Just make sure you say all the right things in there. You can say it in weird ways. All right, what questions you got? So now it says, use the data in the table to estimate the average value. So now we're estimating the average value of WT on this interval using a left Riemann sum. Show the computations that lead to your answer. See if you can get that set up on your own. What do you think the units would be on this? Degrees per minute per minute. Did we take, that's a good thought there. But if this is an average value, let's think about what's happening here. When we multiply these together, okay, so this 1 over 20, what are the units on 20? That's the minutes, right? So this is minutes. When we multiply these two together, these units here end up being degrees, is it Fahrenheit? Or what is this? Degrees Fahrenheit times minutes, right? Isn't that what we're doing there? So once we're done with the units, this is 1 over minutes times degrees Fahrenheit times minutes, right? So it's actually degrees Fahrenheit in the end because it's an average value. It's the value of the temperature. Does that make sense? But since these are being multiplied, that gets divided out, and that's what happens there. Okay. So if you're not sure about the units, think about the parts of the units that you know, and then you can come up with what you need in the end for your degrees Fahrenheit. Okay? What questions we got? We good? All right. We got one more. Find the average value of the function. Hint, graph and use geometry. So go ahead and graph this piecewise function. You can do it. Do you know how to graph lines? Do you know how to graph the piecewise functions? Or are we all just staring at our papers? Are both of these pieces lines? Yes, okay. So we can graph them as lines, but we can also use these things. Don't forget about this. If I substituted a -1 right here, what do I get? 4. So when I'm at negative 1, I go to 1, 2, 3, 4. So negative 1, 4 is one of my points. Okay? Then the other endpoint of that interval is 3. If I substitute a 3 in there, what do I get? 0. So when x is 3, y is 0. And then I can put in that piece of the line. Okay? Then I substitute 3 into this one, which also gives me 0. This is technically an open circle, but since it goes on top of a closed circle, it's fine. It's just the same point. Then I substitute in 6, and what do I get? 6. So I'm a 3, 4, 5, 6, 6. I'm right here. Okay? So there are my two pieces. All right, so if I want to find the average value on this, that means this is f, so the average value is going to be 1 over what minus what? Minus a negative 1, good. Times the integral from where to where? Negative 1 to 6, good, of f of x dx. Since I have the graph, I don't have to do it algebraically. And I have the graph and they're linear. If it was a quadratic, I'd have to do the actual calculus and actually integrate. But it's telling me to use geometry. I can drop these down vertically here so that I can find the areas. What's the area of this left-hand triangle? The area of this left-hand triangle. 8? Y'all agree with that? 8, okay. What's the area of this one? 9, y'all agree with that? 3 times 6 and divide by 2, yes? Okay, I agree with that. So then when we come back over here, this gives me 1 over 7 times, how do I find this integral, given that information? 8 plus 9. It's the area under the curves, right? What if this triangle had been down here like this? And that was 9. What would I do? Make it negative, good, because it would be under the x-axis. Okay. Which it's not, but just making sure. All right. What questions you got? You good? Why do I have so many extras of these? Oh. All right. So we're going to have one more page. No, I don't. Why do I have so many? I think I did too. Oh, no, I didn't. I have it stacked wrong. I was like, I thought we were done, but then, all right, there we go. Let me go figure out how to pause this thing.